Okay, so now we've got the ability to draw a triangle, a square and a pentagon by defining our blocks to draw a triangle, a square and a pentagon. And for each of them we can specify the size of the shape, and when we call each of the blocks we tell it what size we want. Whatever number we put in the space here goes into the size variable and is used within our block. But what you'll notice is there's a lot of commonality between drawing a triangle, a square and a pentagon. In fact, a triangle with 3 sides has a repeat loop of 3. A square with 4 sides has a repeat loop of 4. Pentagon with 5 sides has a repeat loop of 5. So that's something that we can see has got some progression between each of the 3 blocks. The other thing that's different is the angle through which we turn. For a triangle we turn 120 degrees. For a square we turn 90 degrees. For a pentagon we turn 72 degrees. And it's quite an interesting maths exercise to work out where these angles come from for the different sizes of the shapes. And what you realise obviously is for each of the shapes, by the time you've gone round 3, 4 or 5 times, you need to be back where you started. And turning round all the way round is 360 degrees. So the angles here are just 360 divided by the number of sides. 360 divided by 3 is 120. 360 divided by 4 is 90. 360 divided by 5 is 72. What that means is we can look at these functions and we can generalize. We can generalize not just for a triangle, square or a pentagon, but we can generalize for any regular figure of any number of sides, because we repeat based on the number of sides and we turn based 360 divided by the number of sides. So rather than writing a block for triangles, squares and pentagons separately, what we can do is we can write a generic block for polygons for any sided shape. So what I'm going to do is just push those to one side for the minute. I'm going to duplicate my triangle block because I'm going to use that, and think now about what my generic block looks like. So my generic block now needs to come down and repeat for however many sides I want. So I need a new block, make block. I'm going to call it a polygon. I need to add a numeric input for the number of for the size of each side, and I need another block for how many sides I want. So I'm going to call my variable sides for the number of sides, and size for the size of each side, and say OK. So here's my polygon block now. So it's the same, and I repeat based on the number of sides I want. So I use that variable there. And I turn here based on 360 divided by the number of sides. So to do that, I need to go and get one of the maths operator blocks. Here's my division block. And I need to do 360 divided by the number of sides. So this now is my generic polygon block. Let's see if it works. Here's our polygon block. Well, let's do something that we know should work. 3 sides is a triangle. What side's 100? Let's see if that works. Well, hey, 4 sides should be our square. 5 sides should be our pentagon. Let's go mad. 10 sides. Wow. Well, it kind of went a bit haywire because it ran off the top of the screen because our sides were too big. So we just need to reduce the number of the size of each side maybe down to 20. There we go. 10-sided shape was a bit small. 40 be a bit bigger than that. Let's go for 40. Put our sprite back. And there you go, we've got our multiple sided figure. So it enables us to get rid of our triangle block, because I don't need that anymore, our pentagon block and our square block, and now have a much more tiny bit of code that can draw any sided shape we want of any size in a really neat bit of code. And what it allows me to do now is to do quite neat things. So maybe I want to draw a triangle of size 50, and I'm not going to just draw one triangle, but I want to draw lots of triangles. So I'm going to take that and I'm going to put that in a repeat loop, and I'm going to repeat it 36 times. And between each time I draw the polygon, before I start drawing the next polygon, I'm just going to turn the sprite by 10 degrees. So you should draw a triangle, turn by 10 degrees, draw another triangle, turn by 10 degrees and draw another triangle. Let's watch what happens. Well, something happened, not quite what I was expecting. Seems to have just drawn the one triangle, but we saw lots of work going on. It's because each time we drew the polygon, we cleared the screen. So I'm going to take the clear out of my generic draw polygon, and I'm going to put that in my code. I'm going to make it a little bit bigger, maybe 75, and run my bit of code. And there you go, I get a nice shape. Obviously, very easily in my code now, I can come and make that a square of the same size and rerun it, and I get a different pattern. You can see how neat and tidy that code is. It's what we call modular programming. We've taken the concept of what we wanted to do, to draw something, and we wrapped it up in its own block. And then we realised the block was quite a general block. It was really the same block, no matter whether we wanted to draw triangles, squares, pentagons, hexagons, heptagons, octagons, nonagons, decagons, 1,000-sided shape. It really doesn't matter. We could generalise the function, and this block now, or function as we know it when we talk about programming, can draw any sided shape. So just as the last one, let's go really mad. I'm going to draw a 100-sided shape. I'm going to make it quite small, 5 times long, and see what it does. Well, funny enough, a 100-sided shape, because our circle is quite small, our shape is quite small, actually looks like a circle. And there you go, it's going round, drawing the pattern. And I'll leave you to finish that one off yourself.